Hi there. Today we're going to explore the brain teaser that a lot of teachers like to assign, which is how do you convert a repeating decimal to a fraction? A decimal that never terminates, how do you turn that into a concrete fraction? There are lots of great ways, and I'm going to show you one of them today. So there are lots of great ways, but today we're going to explore the idea that zero point 0.7 repeating is actually a geometric series. A geometric series means it is a series of numbers that all have a common multiplier to get from one number to the next that you sum up. Okay, what does that mean? Well, let's take this and start looking at each place and write them as fractions. So 0.7 can be rewritten as 7/10. And the 7 in this place can be rewritten as 7/100. And the 7 in this place can be rewritten as 7/1000, and so on and so forth. And if we were to add all of these up, that's where we get all of our 7s in the correct places. So if we now look at, is there a common multiplier to grow from 7/10 to 7/100 and 7/100 to 7/1000 and so on and so forth? The answer is yes. We multiply each term by 1/10 to get to the next term. So now it's time to write some formulas on the page. First, let's just write the general formula for a geometric sequence. So that's a sub n, the value of the nth term, equals a sub 1, the value of the first term, times r, the common ratio, raised to the n minus 1, the number of your terms minus 1. And now let's fill that in with the numbers that we've got here. Okay, where 7/10 is our first term, our a sub 1 term, and 1/10 is our r, our common ratio. So now let's put a second formula on the page, which is the sum of an infinite geometric series. So this is infinite because it's a repeating decimal. It goes on forever. And the key to having something that is infinite also have a finite sum is when your r, when your common ratio is between 1 and -1, essentially it's fractional, then your terms are getting smaller and smaller and smaller until they become so small as to be negligible, which means that if we add everything up, eventually we will be adding a negligible amount. And therefore, when our common ratio is fractional, we can actually find the sum of an infinite series, the limit that we're approaching. And that formula goes like this: the first term divided by 1 minus the common ratio. So let's put our numbers in here. Then let's simplify. And then let's remember that when we divide a fraction by a fraction, we flip and multiply, and we cancel. And we are left with that 0.777 repeating can be rewritten as this geometric sequence, which can be summed using the infinite geometric sequence sum formula to find that our answer is that 7/9 is how we write 0.7 repeating as a fraction. Okay, now that is one of many ways. So if you're interested in seeing another way that actually does not involve geometric sequence and series at all, then check out this video and feel free to send in your comments, some more brain teasers so that we can keep on mathing.